we do understand you might need to have a little bit more examples of the three diagrams we showed last week. So this is another video to help you understand the concept a little bit better. So for this one, firstly, we are going to look at the initial class diagrams in here. One thing you need to understand for initial class diagram is to make sure all of the initial class diagrams classes are going to be entity classes. They do not have control class, they do not have boundary class. Remember, for initial class diagrams, all of them are entity classes. And the second thing is make sure that you have a class that resembles the systems in here. The class that resembles the system is going to be converted into the control class when it is going to be converted into the detailed class diagram. But at the current stage, when you are trying to understand the relationship between entities, you need to make sure you have a class that resembles the system as an entity classes in here. Besides that, you also need to think about inheritance relationship as well. So for the inheritance relationships in here, you need to understand whether they have generalization relationship or polymorphism in here, which you will have a class, a parent class that have all the attributes that is going to be inherited towards all the child classes in here. So if you have this kind of inheritance relationship, that just means the child is going to have all the attributes that is declared inside the user's class in here. But for this diagram, they do have a little bit of issues, which I'm not going to tell you in this case, but have a think about whether it is appropriate to have three empty classes that is going to be inheriting the parent's class. Then after that, you also need to think about all the rest of the entities that is occurring inside the case studies in here. Please make sure all the class namings are following the coding standard so that in the later stage when you convert to detailed class diagram, you do not have issues in terms of the class diagram namings in here. Besides following the coding standard, please make sure all the class naming is using singleton views. Do not use plural. If you're using plural, that's making the class diagrams not class diagrams anymore. Another thing here is for your attributes, you need to make sure the attributes follow the coding standard in here. So these diagrams does not show very well in terms of the coding standard. So you need to make sure if you are using Java, you use camel case to name your attribute. If you're using Python, you use underscores to link the attributes in here. So that's another thing to understand. The next thing you need to think about is aggregation relationships. So as we mentioned before, we only look into aggregation. We do not look into the composition for this unit because most of the time you guys will get confused about that. So we only look into the aggregation. As we mentioned in the lecture before, the aggregation is using white diamond, which means the relationship is not going to be strong between the two classes. And in this case, since the relationship is not going to be strong, another class is going to be exist without one of the classes in here. So in this case, for example, for the store and bake shop system, the store can still exist without the bake shop systems in here. So that's why they have the aggregation relationships in this case. I won't comment about all the rest of the aggregations in here, but you need to think about this part. For the next part, you also need to think about the relationships in here. So please make sure you do not use n to represent many relationships in here. It needs to be 1 to stars in this case. But if you have 1 to star relationships in here, you need to make sure the attributes inside your class diagrams are going to reflect about the relationships in here. So if you have one-to-many relationships, in this case, as a class diagram design, you need to think programmatically of how the object is going to be created. In this case, if it is one-to-many relationships, the many part is going to be a list of objects in here. For example, you will have a list of users inside the bake shop systems in order to represent there will be one-to-many relationships in here. So I won't comment again in terms of the rest of the designs, but you need to think about the differences between the one-to-many and one-to-one or many-to-many in here. So the last part you need to be reminded of is going to be the black triangles in here. So for the black triangles, it's just meaning the direction of the relationships in here. The direction of multiplicities is usually one-to-many relationships, and one is usually on the left side. So just try to remember about that. Of course, I'm not going to comment about the rest of the designs inside these diagrams, but remember, this triangle, it just means direction of relationships. They can be either placed in front or they can be placed at the back. There's no differences in here. Basically, that's going to be all the things that need to be careful when you make the designs in here. But again, in order to identify the correct entity relationships or correct class in here, you need to go through the dictionary of abstraction, which is provided in both lecture slides. In both lecture slides as well as the week 6 tutorial and also your assessment in here. So that's going to be your initial class diagrams in here. So the next part is going to be the sequence diagram. For the sequence diagram, the first thing that you need to understand is you need to make sure this is going to be the role of the system. Try not to use user as a replacement in here because it does not make any sense. And if you have multiple roles inside the system, it's going to be very hard for people to understand what role you are having in here to interact with the system. After that, you need to make sure that you are having the boundary class and also the control classes in here. Please make sure you notice about the columns and underscores for the indication of the class object in here. So as we mentioned in the weekly lectures in here, for the boundary, they are in charge of display of information, and for the control, they are in charge of the business logic in here. So as of now, we still have the entity classes that is going to be represented as the systems in here. Later, this one is going to be combined into the control class. But as of now, since we are creating a sequence diagram based on the initial class diagrams and in the use case scenarios in this case, so for this one, we still have the class that resembles the system. And after that, we will have another entity classes that is going to be used in the project in order to be used for getting the information from those entity classes in here. So for the sequence diagrams, you need to remember that sequence diagrams are following the chronological order. So starting from the user, and then every events that is happening within the sequence diagram, you are going to go to the next stage in here. And for this part, you need to remember this kind of descriptions in the later stage will be converted into the actual method you are going to call in order to achieve the necessary requirement in here. But as of now, for the sequence diagram you are going to do for the assignment, since you haven't started development yet, this part is okay to create like this. It is not necessary to use the actual method name at the places where you have this kind of events happening. The next part for the sequence diagram is about validations. So this diagram does not have too many validations in here again, but remember, for your sequence diagram, you need to make sure that if the users are trying to interact with the system by entering the information into the system, for every information they entered, you need to have necessary validations in place so that you can perform the validation on the entry that user made. So the user's entry can happen inside the control class. For validations, they can also happen at the places where you are trying to get the information from the entity classes in here. Because at the end of the day, if you put too many validation methods into the control class, it's going to be very hard for you to find the relevant validations in relating to the entities in here. For example, if you have 5 entity classes with around 10 validations, putting into the control class, you have around 10 methods to be used for validation. However, if there's a double amount of validations for each of the classes in here, that means you have 20 methods that is just talking about the validations, which is going to be unnecessary and very confusing to the users or the developers in here. So for this kind of validations, unless it is common, such as validating the user's entry to see whether they are empty or not, if the validation is in relating to certain attributes inside the entity classes, the validation needs to happen at the class where it is at the class where the attributes is defined. After that, for the retrieving of information, usually it's going to come stage by stage, like what this one is showing up in here. But in terms of returning the data needs to come back from the entity classes where the information is stored. But please be reminded that the entity class cannot directly jump to the boundary classes in here. They need to go through the control class, which is going to be act as an intermediate middleman in here in order to send back to the view classes. This is to enhance the security of the data passing mechanisms in here. It is also going to help people understand the way of passing easier, because this one contains all the business logic. So in order to pass this kind of operations in here, you need to send it back from the entity to the control in here. After they send back to the control, the information can be then further sent back to the boundary class in order to display the necessary information accordingly. But please be reminded that starting from here, this part cannot reach to the users straight away unless the users have a chip in their mind, as we mentioned before. Unless the user have a chip in their mind, they cannot directly receive the messages that is from the boundary class straight away. So what this one is going to do is, after they come from the control class to the boundary classes in here, it is going to end, and then waiting for further input from the users here again. So this is how you are going to do the initial class, the sequence diagrams in here. But another thing that you need to be reminded in here is do not include the concept that is not covered in this unit inside your sequence diagram. Also, I know some of them might be beneficial. For example, the life length, which is going to be the square shaped sized shape in here to cover the life of this activity. But as of now, for this unit, we do not need to cover that. It's going to be the same with wrapping some certain events into a loop or mention about the exception flows in here. The sequence diagram should be very straightforward to just include the sequence of activities based on the use case scenarios you have generated. And even for the use case scenarios, that's going to be just based on the flow of events inside your use case scenarios to draw the sequence diagrams in here.